Okay, well, welcome to pavement smoothness training for trainers, I should say. The goal out of this class, when we reached out to Headquarters Construction, we asked for people that would come forward and be sort of the first implementers and the experts in the district. We want you to take the knowledge back that you're learning here today and use some of the tools that we're presenting here today and take them back into your district and be able to represent your district and share the knowledge. So another thing we're doing here is we're trying to record this session, and we're going to post this on our website so people will be able to look back and refer to this. Receiving pavement smoothness training in February is probably not too conducive to implementing in the paving project that takes place in July. So we're hoping that as you look back, you'll be able to use the video, use some of the tools that we have, and some of the knowledge that we're trying to present today, and help your staff implement these new specs. So anyway, I want to welcome everybody. My name is Blair Anderson. I'm the office chief for construction standards with Headquarters Construction. And I am joined today by two of my staff. Pete Spector is the asphalt pavement smoothness subject matter expert for pavement smoothness, and Deborah Yost, who is our concrete pavement subject matter expert. And as well, we've got a couple of people in the class today. We've got Saeed and Alan King with the Office of Pavement, who they are the spec owners for the specification. Today this is just kind of shows our agenda. So this morning we're going to go over some of the background and informational portions of the spec, and then in the afternoon we're going to go through the payment adjustment spreadsheet. So in the morning we're going to go over all the specs and kind of the theory behind it and what's out there. But that spreadsheet is a tool for making payment and paying the incentives and disincentives. And then we're going to have just a brief quiz and the course evaluation. So my goal today is for all of us to share a little bit about ourselves. You can see that the past smoothness spec had some really hard limits, like you had to target 60, target 70. You had to grind into it, and it was the spec was literally a grind between the RE and the contractor. There wasn't a lot of flexibility in the specification. My other goal today was asking you your favorite place. I'm hoping to put a little smile on your face, put you in a better mood when you're, because the spec in the past has been a little bit tough. I want to talk a little bit how inertial profilers have improved our safety. So in the past, we used to have to go out and do the California profilograph and walk the grade to check smoothness. Now with the inertial profiler, you can drive through, at traffic speeds, freeway speeds, and test for pavement smoothness. And then at Headquarters, there's been a lot of focus recently on safety, so I just want to share this out to you guys a little bit. These are some of the Caltrans held a safety summit with our industry partners, and we were looking at trying to improve some safety things. So some of the things they're looking in are to promote temporary speed reductions in some work zones. They're looking at that by possibly reducing speed by 10 miles an hour. Work zone intrusion alarms, overheight early detection alarms. They're looking to try to utilize full closures a little bit more, positive barriers, vehicle speed feedback things, improved work windows to minimize traffic impacts. And then they got some flagging specs that they're updating. They're looking to improve work zone lighting for the flagging stations, and then automated flagging requirements. Buffer lane specs are back looking at buffer lane specs. And then I think we talked about the intrusion zones and backup alarms. So I want to go into the spec a little bit, some of the background and history. So we've got new specs in section 39, new specs in 40, 36.3, which it's the precursor to the asphalt pavement. That 36.3 is going to be a complete update. So we're going to have a whole new special provision. We're just, rather than tell you, what paragraph and section has changed, we're going to have a full update on that section. So you won't have to go and piecemeal look through your specs and figure out what paragraph or what table got added. It'll be a full new section. This effort was a collaborative effort with maintenance, Division of Construction, METs, and industry. So maintenance is a spec owner. Both the concrete pavement and the asphalt pavement groups are the spec owners. These are performance-based specs with achievable target limits. And they just issued a letter last week, I believe, with the design, the deputy of design, and maintenance joint letter on all projects coming out in the spring. So how did we get here? So if you roll the clock back in, I'm going to say fall of 2017, Caltrans had sort of looked at trying to put incentive-disincentive requirements specs together, and I believe it was routed to industry for review and comment. And industry, ABC of San Diego, came out with a letter to Malcolm and cited what they cited achievable smoothness requirements for both concrete and asphalt with some recommended MRI values. They didn't really like what we were going to roll out. They kind of pushed back a little bit and came to us with some changes. And then CalAP, which is the California Asphalt Pavement Association, both engaged also at that time and came back with some similar requirements. So the letter cited some pavement smoothness limits, specific. So they came back with incentive ranges, full pay ranges, disincentive ranges, and then mandatory correction ranges for the various concrete pavement types, CRCP, JP, and then they even jumped into the hot mix asphalt thing. But we'll get into what we did a little bit more as we dive into the meat at this. But they basically came up with new target zones for the different. They got a target 60, 67.5, 75 for concrete, and then we've got 60, 70. All have the percent improvement opportunity, which we'll tell you a little bit more about as we get into it. Why are we doing this? Why is smoothness important to the department? It reduces fuel consumption, so it helps in greenhouse gas. Okay. So we want to incentivize good paving practices, and that's important because we want to reward good paving, and we want to give contractors the option to take deductions in lieu of grinding, and then we don't want them to grind into incentives. So we don't want to have them put incentive money out there and grind to get the incentive. So we're not allowing that in the spec. And then SB1, owners of choice and partnering. So with the SB1, we're in this fight with the contractors. There's a lot of work to be done out there in the coming year with the increased SB1 money, and we're trying to work with our industry partners to develop achievable specs. And then most of all, we want to try to reduce grinding of the new pavement. So these new specs, like I said, we want to reward or incentivize excellent paving. They get full pay, and there's a wider target zone for achieving pavement smoothness, and Pete will get into the targets. And then corrective action, we've got optional disincentives. So they have the option of taking the disincentive in lieu of grinding, and then we've got mandatory correction zones where we're going to basically, if you don't meet the mandatory limit, they automatically have to do grinding. So if you look at the left side of RTL, there's a automated pavement condition survey, APCS, and this is a survey, annual survey. All the roads in California are run by the pavement group, and the condition is put into this survey, and it's available online. And so they've got this interactive pavement map that shows the pavement condition, the existing pavement condition through all the roads throughout the state. And this is sort of how your jobs get targeted and put forward for contract. So if you go back to the map, you can see that they're color coded over here with yellow, red, green, and then this is what it represents. So for preventative maintenance, you can see green, little to no surface distress, yellow is minor surface distress, blue, poor ride, minor structural distress in the orange, and then major structural distress in the red. So your CAP-Ms would be in here in your minor rehab, and then your major rehabs would be over here in the red zone. So types of asphalt pavement distress, obviously cracking. This is popular down in Florida, the alligator cracking. And then rutting over here on the right. So typical repair strategies for preventative, we would be doing seal coats, dig outs, or thin overlays. For corrective strategies, we'd be doing dig outs and thin overlays. And then for rehabs, we could be doing full lane replacements. So the design for smoothness is a process change. It's a process change for the designers, and there's a process change for you guys with these new specs, and that's what we'll be getting into today. So for designers, they're going to be, right now the Alan King and Saeed and these guys are going out to every district and basically talking to designers about how to implement these specs and design for pavement smoothness. So they're on the plans, they're basically defining the target MRIs. For HMA, you've got a target 60 or a 75, and depending upon the existing pavement condition, it would revert to what we call percent improvement. For concrete, we would be targeting 60, 67.5, and 75, and then grind existing. Supplemental funds are going to be put into the projects to pay the incentives. So there's guidelines in the standards in the SSPs. Based on the lane miles for them to put supplemental funds into the estimates. And there's bid items for pre-paved corrections, which are dig outs, partial or full width segment corrections. And then the designers have the opportunity to determine whether or not that the mill and fill will be allowed to remain open prior to paving. So if they, typically they want to mill and fill in the same shift to reduce rocks and windshield breakage and all that type of stuff. But if we're allowed to leave it open for more than a single shift, it creates a second opportunity. And Pete will be getting into a little bit more later about opportunities and stuff. So this is a plan sheet. A little bit hard to read from back there. I've got a little bit of a blow up. So if you look here, they would be defining this one has pre-paving corrections, but you can see that the target MRI is a 60 on this job. If you go up here, we've got full width segment corrections. They've got some stationing and some each items in here based on for the northbound lane, southbound lane. Partial width segment corrections are shown on this particular plan, and then some replace asphalt concrete surfacing items. Semi-permanent reference points. So they show these with northings and eastings and also some stationing. So these would be the help for the IP operators, so we have consistent stationing, so it would help reference some of the existing pavement conditions that we're putting in the plans as a material handout, and then the contractors would use these semi-permanent reference points when they go through and perform their inertial profile or gather their information and do their inertial profile surveys. So an overview of the construction project. We'll be getting into this slide in a lot of depth, but this just kind of shows it's a change for you guys. So there'll be smoothness quality control plans will be submitted. We've got Caltrans witnessing and receiving the contractor's inertial profiler runs, and these are the runs. These are asphalt runs, existing, baseline, pave, and final. Pete will be getting into that. We want to review and verify the contractor's runs, and he will be submitting these payment requests as part of our payment adjustment spreadsheets, and then calculating and agreeing. So we want to review and verify their payments, adjustments for their bonuses, incentives, or disincentives. And then at the end, once you guys have agreed and made payment, then you would submit it to headquarters so we could analyze the data in the future to make sure that we've got an appropriate spec. It's an NSSP. We haven't really gone out with this spec, so we want to verify. There's a group that's going to be studying the spec over the coming year. So going back over these key points, so these are final surface MRIs. They're performance-based. There's the full pay range, mandatory correction levels, optional correction or deductions and a little grinding. We're not allowing them to grind into incentives. There's percent improvement on asphalt jobs is always in play. We're still using a certified inertial profiler, and we still will be doing department testing for verification. Typically, at least, FHWA expects us to do about 10% at least of verification. But in lieu of verification, we can use contractor data to make payment. So that's basically what it's saying, smoothness acceptance is using contractor test data. Caltrans, we want to witness the test. So, part of talking with FHWA is us to be out there to witness a test, and then we've got requirements in the spec for the contractors to give us the raw data. When they run that test, give us the raw data within 12 hours or the same day as the test. And that's to protect the integrity of the test data. And then for us to validate, we still could use Caltrans people to come out and rerun the final smoothness. Bid packages will still have existing smoothness profiles in them. And then the smoothness limits will be shown on the plans and in the spec. On the concrete spec, there's a spec table. And then contractors to verify smoothness and inform the RE when the existing smoothness and inform the RE when it varies more than 10%. So, when we provide that existing smoothness data in the profile, he goes out and runs it, and it's not within 10%. He's supposed to let the RE know. Contractor to submit payment adjustment sheets, and Pete will get into that. We're utilizing ProVal project files and the MRI put into our spreadsheet, and then Caltrans verifying the spreadsheet and processing payment in the supplemental funds.
Of the presentations. So.
Okay, thanks, Blair. Can you hear me all right back there? Or? Okay. We'll go ahead and cover some definitions. A lot of you probably already know these definitions by now, but we're going to cover them again in case you don't. So areas of localized roughness. What that is it's basically similar to the old musk grind or a bump that you'd find with a straight edge, except it's evaluated with the inertial profiler. So wheel paths, that's where basically the specs were revised recently. They used to say 3 feet in from the edge of traveled way. Now it's 3 feet out from the center of the lane, so which cleans things up. It didn't really work correctly if you had a lane that wasn't 12 feet wide, so that cleaned that language up. ProVal stands for the Profile Viewing and Analysis. So this is free software that the feds provide to all these states. So there's a lot of functions in this ProVal software that it can do a lot of different things, and it's designed for a lot of different states. We're going to go into one module out of, there's like 8 or 10 modules in that software. We'll be using one of them. So, okay, per the contract, measure the smoothness of. So we have all these different profiles. You saw that slide earlier. It's talked about existing, baseline, pave, and final. Our specs basically require the contractor to put this text inside the file name for these different profiles that we're going to be getting. So if we have an existing, there's a section that's got all this covered. So if we have an existing surface that is basically goes through a winter suspension, or it's out there longer than 30 days, the contractor is supposed to, let me back up, supposed to rerun that, and you'll have a second existing file that would be called existing R, revised. Baseline is the existing pavement segments if structural repairs are made. So we're always going to have this file. If there's no structural repairs made to the existing surface, the contractor can take that existing file and just rename it. So pave is obviously after you pave. Final is after you make any corrective actions. If we have open graded, right, we want to be able to keep these files separate from all the existing, all the standard HMA type projects. So we're going to put O on the end of those file names. Okay, the International Roughness Index. So this is a worldwide standard that pretty much every state, I think most states have adopted it now, like 40 or 50 states. So it's a quarter car simulation. So it's essentially, this inertial profiler goes out and measures the road profile, the wheel tracks. All that profiler does is give us the elevations of the road every inch. So to analyze the International Roughness Index, basically you run a quarter car model. It's a single wheel with defined springs and suspension, different masses. And it's basically an algorithm that calculates IRI. So when we think about IRI, there's a IRI value for every point along that road. And we're going to be looking at averages. If we're looking at localized roughness, we're looking at the average IRI values of all those points over a sliding 25-foot segment. If we're talking about MRI, we're looking at the average roughness of both wheel paths for a 10th mile segment. So here's a plot that, a graph that kind of shows how you calculate MRI. So if we looked at all the IRI values in this 10th mile segment, it starts at the left side of the screen and runs to the center. And we said the average of all those IRI values is 62. We did the same thing for the right wheel path, 58. Together, all those values average to be a 60. That's the MRI, 60. So when you go into ProVal, there's an option where you select IRI or MRI. So IRI in ProVal, they're talking about the roughness of a single wheel path, and MRI is the roughness of, you're analyzing the average roughness of both wheel paths. Okay, so the Inertial Profiler Certification Program. So all our profilers that we use on the projects have to be certified annually. That's covered in section 36.3, the requirements. So the Inertial Profiling Certification Program, it's basically certifies the operators and equipment. They wanted to make sure I tell you that it's not a training program, so it's a big red X through there. All they do is certify the equipment. So if for inertial profiler operators, Caltrans or contractors, if they want to sign up for this, they can go to this website and find the schedule and request that they be signed up for the certification. So once they're accepted into the class, they'll basically be tested on CT 387 and some ASTO test methods, R56 and 57. 56 is the standard practice for certification of the inertial profiling system. So that's the test that defines how to, that certifies the profiler. 57 certifies the operator of the profiler. So that certification program certifies the inertial profiler operators and the equipment. Okay, so part of what they do is they basically will run out to a project. After they do a written test, they'll run out to a test site where they know the actual roughness, and they'll basically run all the different tests that you'll run to certify the profile. The first test that they run is basically the block test, the bounce test, and the DMI test. They make sure that this makes sure that the inertial profiler is working correctly. And the second test is a cross correlation test, and what they're doing is they're running through the 10th mile segment 10 different times, and you want to be able to repeat and get the same kind of values within a certain tolerance. So they do this test annually, and that gives them their certification. And also, this block test, bounce test, and DMI test is also required every single day on a project before they go run an inertial profile. So there's
specs say it would be witnessed by the engineer.
Yeah, and the specs also say that this is to be witnessed by the engineer. So then we also have a requirement we're going to have our inertial profiler operators, the state's IP operators, they're going to run verifications of the contractor's profiles. They also have to do this. So if we can't pull up these records when we run a verification, they didn't do the certification, that verification's no good. So we have to have those records daily. Every inertial profiler operator has got to go through this block bounce and DMI test daily, so to certify that the equipment is working correctly. Then also the specs also call for a cross correlation test one time on the project per year. And that's where they'll run through that 5 times. So, but daily, I can't stress this enough, is our inertial profiler operators, we've got to make sure that they're certifying, that they're doing this DMI test every single day. Okay, this is once they are certified, the IPCP program will give them a certificate and also put these stickers on the actual lasers. They have the accelerometers on the left and the right. So this operator, he's certified for a specific model. Here it says SSI CS900, CS9300. He's certified to run this inertial profiler. This is a model CS900. If you were to come out and run a different profiler, he's not certified to run that profiler. So the operator certificate goes with the inertial profiler, the model. Okay, so I spoke about this earlier, the block test. And you'll hear people use this term block, bounce, DMI. It's like, I'm going to basically explain what that is. So the block test, initially they're going to check on the inertial profilers, on each side of the profiler, there's a box here. It's got a laser beam in it. It's got an accelerometer in it also. So this exists on both sides of the inertial profiler. They'll set a steel plate down, and that gives them their reference elevation. Then they'll put a 1/4 inch plate down, and they'll take a laser measurement. And they can figure out, the laser is going to tell them that it raised up. The distance is a 1/4 inch less. They repeat it for 1/2 inch, 1 inch, and 2 inch. So they go through all those measurements, and they have to be within it. 1/100th of an inch. So these these measurements are reading out to the thousandth. These lasers are accurate to, they have to be within 1/100th of an inch, 0.01 inches. So, okay, now the bounce test. So this is basically what this does is basically there's a static test and a dynamic test. They call this whole test a bounce test. So the first test that they'll do is they'll basically put it in the static mode. And we can see the steel plate here. They'll shine that laser beam on there. And this truck is obviously not moving, right? He's not bouncing the truck. He'll go into the inertial profiler software, and that software will mimic driving down the road at 50 miles an hour or whatever. So he's going to drive through a 10th mile. The computer simulating him driving through a 10th mile. So as the grade of the road's not changing, that inertial profile should be glass, right? It should just be smooth, so the IRI should be 0. Well, if he gets a reading of 1, 2, or 3, or anything less than 3 inches per mile, he passes that static test. Okay, then the next test that they do is the dynamic test. So now he's bouncing this, and this truck is the computer simulating driving through a 10th mile, and it's bouncing. The accelerometer is basically canceling out all the suspension, and it's calculating elevations of the accelerometer. And the laser's changing distances. Well, the reality is the road is still theoretically a sheet of glass, so that IRI should be 0. Well, there's a lot of noise in these laser beams, electronic noise, these sensors, so there's a higher degree. So if it reads an 8 or less, he passes. So, and the DMI test, this is basically where they run through the 10th mile segment 3 times, and it's got to be within a foot of 528 feet. So, okay, the cross correlation test, this is just a screen that shows a passing test and a fail test. This is one of the modules that's in ProVal. They basically run a section of road 10 times, and they feed all that information into the software, and it does some statistical analysis. It tells them if they drove the same course accurately. If they waved off if they skewed a little bit off course, you'd have different IRI values, different measurements, and it wouldn't pass. This is a sheet that's used for when they're doing the certification. So we can see the block test, bounce test, longitudinal test, and then that test where they're doing the profile collection running 3 times. Okay, so inertial profilers. So there's 3 basic models. SSI is the most common one we see in California. All of our districts except for District 4 have a SSI. Most of the contractors have SSI. There's a reason. I think these are probably, if you went out and purchased one of these, this must be the best price. That's the reason most of these contractors are buying this model. Dynatest, it's a second model. And there's an Ames model also. District 4 was one of the first districts to get an inertial profiler. I think that's why they ended up getting an Ames. So
Kind of. It was a trade.
it was a trade.
District 6 gave us the aim, we took the SSI.
Okay. So District 6 used to have the Ames, and they took the SSI, and then District 4 took the Ames filer. So, okay, administration of the specs. So, Section 36.3. So Blair was talking about this earlier. Section 36 is a general section for all pavements. There's a lot of information in there. 36.3 is the subsection that is general for smoothness. So 36.3 is essentially laid out in this fashion like many of our specs. There's a general section, materials, construction, and payment. So under general, we have submittals, definitions, summary. So all those sections still exist, but we added some sections. This next slide shows the sections that we added. So this whole 36.3 is getting replaced in the NSSP, so you don't have to insert all the different paragraphs. You'll have the whole section. So the main things that changed are the submittal requirements. So we have a smoothness quality control plan that's required. We also have a smoothness payment adjustment request. So the purpose for the smoothness quality control plan is when we start analyzing a lot of profiles and comparing one to another at different times, it's been my experience that every time I try to compare one profile with another, the DMIs don't measure. They don't align with each other. You can look at them in the software, they just don't line up. So the main purpose for this quality control plan is to do what we can to make sure every profile lines up with the previous profiles. So this basically is going to, this quality control plan is going to have a layout sheet that defines what the beginning station is, and if the stationing for that DMI increases or decreases. So anybody that comes out to the project that's going to be running an inertial profiler, they'll take this quality control plan and use that same station. So that station is also has to have a nail on the ground or some semi-permanent reference point that's maintained throughout the life of the project so that everybody can start from that same location. So, and we have requirements for the PPF files. So these are the raw data profiles that come out of the inertial profiler. The inertial profilers can give you a lot of different formats. This is the standard format. It's just raw data. All this file is just elevations. There's no IRI data in it. It's just PPF. It's just elevations. We feed these into ProVal to come out with the IRI values. Okay, and then the smoothness payment adjustment request. So this is new. This is where the contractor's got to do a lot of things to get these profiles to line up. We're making sure he goes through all those steps before he gives us payment adjustment request. If these profiles don't line up with each other, he's non-compliant. He'll get a withhold until he comes into compliance. So part of this adjustment request is a ProVal project file and a payment adjustment spreadsheet. For every line, you're going to have these two files. These go together. This ProVal project file is essentially all the PPFs into one file, all zipped up. You can double-click on that PVP file, and you'll see all the profiles, and they should all line up with each other. So the contractor has to go through that step if he wants to get his adjustment. If he doesn't do that, he's going to be non-compliant. There'll be a large withhold until he comes into compliance. So, okay, so the quality control plan layout. So the semi-permanent reference points. So I talked about this layout plan earlier. These semi-permanent reference points are really important. So we're going to establish a semi-permanent reference point at the beginning and the ending of the project. And it's based on the plans. So if we have a project that's 10 miles long and they're doing this in two different stages, the first year 5 miles, the second year the second 5 miles, we want the contractor to run through the existing profile from beginning to end. So he'll have a beginning station for that first semi-permanent reference point, and he'll have an ending station for that last semi-permanent reference point. If there's any bridges in between, he'll have semi-permanent reference points called out on his layout plan. A person could, if they had to, like in year 2, they could start in the second 5 mile, and they don't have to run the whole profile again when they're doing their pave or their final profiles. So we'll cover that in a little more detail. Okay, there's a requirement for locating and how these semi-permanent reference points are labeled in the field. So we have a standard naming convention that they should be following in the spec. If you walk up to and you see a semi-permanent reference point on the shoulder, you should be able to look at it and say that's at this station, and the station's increasing or decreasing. You can basically start your inertial profiler at that point and initialize your profiler using that station. So KMZ files, these are also required to be submitted in this part of this quality control plan. A KMZ file is basically just a file that when you click on it, you can go to Google Earth and you'll see the coordinate information. We want them to take color photographs of these semi-permanent reference points that they've placed in the field. So anybody that pulls out to the job site, they have a better chance of making sure they find that semi-permanent reference point. And also GPS coordinates. So with this KMZ file, you can also get GPS coordinates out of that. Okay, so the pavement profiles needed are a function of the type of pavement we're building. If we're building HMA pavement or asphalt pavement, we have 4 profiles we have to get. If we're building a new concrete pavement, we don't really care about the existing or baseline. We just want the pave and the final. And if we're grinding existing concrete, the specs for grind existing, they essentially say you have to get a 40% improvement over the MRI that's out there. So obviously we need to know the existing and we need to know the final. But we're going to ask for the baseline file because we know they're going to go run that baseline. That baseline is going to be run after they do any slab replacements or anything. This doesn't come into the payment equation, it's just information that we want, because if we don't require them to give it to us, they're not gonna give it to us. We know they're gonna run it. So,
Peter, I have a question on that one. We have a project where we have a claim. So we're trying to see the percentage improvement after they pave and before they do the final corrective grinding, but because they are not required to submit, they did not submit. So would it be important to include it, or so they submit? So.
well, I mean, you have an asphalt project right now where
Right.
there's a claim and they're,
Yeah, it happened 2 years ago. So we don't have the profile after they pave, which is not, they are not required to submit.
they are required in the old specs to submit that profile.
No, I think that's spec they were not required. It was 2 years ago.
Yeah.
So what happens is now to analyze the claim, the quarters, they wanted to see the percent improvement after they pay, right? We have the profile after they did the corrective grinding, which they comply. But the amount of effort, the grinding they did to meet the spec. So since we don't have the profile after they finish paving, we couldn't really compare the percent improvement after they finish the paving. So, so I was just wondering, I was hoping this new spec would include the contractor would require to submit the pavement profile after they
Yeah.
finish the paving, yeah.
Okay, so with this new spec, the issue that you had on the other project,
Yeah,
those files were, I believe, required to be submitted, but they were supposed to be uploaded to a website.
they
The
were-
difference between the old spec and this new spec is that they have to give us notice when they're gonna go out and run these profiles. We're supposed to go out and witness them. Ideally, they'll give us a thumb drive with these PPF files on it out of the truck. Because the spec says, within 12 hours of the same day, give us these files. We don't want them taking off and then forgetting to give us the files or modifying the files. We have a time frame on how soon they have to submit these. They're supposed to give these directly to the engineer, these pavement profiles. So I don't know if that answered your question or.
Yeah, I think it would help because what happened in the past, we're not really, the contractors were not submitting the files on time. That was the other issue also.
Yep.
And then not having the same reference points was a second issue.
Yeah.
So I think that would help.
A lot of what I think, a lot of the issues we had in the past are this is something that's fairly new. These inertial profiling specs, even 2 or 3 years ago, was new to people. They didn't really understand what was required. Contractors have a tendency to, if there's something if they're going to give you information, the only reason they're going to give it to you is if it benefits them, right? If they have information that's not going to benefit them, they're not going to give it to you. They have to give it to us. It's part of the spec. So,
Thanks.
yeah, so you can call Wahid Maroof. He has access to all those electronic files that were supposed to be uploaded. Chances are they probably didn't upload the files, but. Yeah. Okay, so again, every one of these profiles have to be submitted immediately after running them. So, in the old specs, we had existing, and then we used to call this inter. This was like, it stood for intermediate. Now we call it baseline, and we'll cover that shortly here. And I think the last file that we ran was called correct. Now we're calling it final. It's the final file. It's the one that meets spec. So, okay, leave-out changes. So section 36301D3B discusses leave-outs. So every one of these items is now covered as a leave-out. Areas within 15 feet of manholes, weigh-in motion stations. Essentially anything that's out in the traveled way that, is essentially going to cause a bump that they were out of their control. There's this last item here, gutter pans. That's red and struck through because that is in some of the NSSPs right now, and we're trying to get that taken out of that because what that says is if we have a shoulder that's 15 feet or less, we don't have any MRI requirements on it, right? That doesn't make sense. I think this was intended to maybe be a gutter pan that runs across the traveled way like you'd see at intersections. So this is getting taken out. Where industry wants to, if they have a shoulder that's 8 foot or 10 foot or greater, they want to, if it's less than 8 feet, they want to be able to waive the whole shoulder. I think it should be something less, but this is something that we have to work with industry and come up with an agreement. So, if we can contractors can pave the through lane. They're supposed to pave the through lane first, and then if there's a gutter pan that they're having to tie into with a conform grind, they can come back and make a second pass, and there's limitations on how, what's economically feasible and what's realistic, so we have to come to an agreement on what that is. It'll probably say within X feet of gutter pans, so. Areas within 25 feet each side of intersections. So before we didn't have any language about intersections. So there's a lot of intersections where we have stop signs or stoplights, and we couldn't measure the MRI when you had to come up to a stop sign, right? So that's going to cover this. If this needs to get changed later because there's contractors that are interpreting driveways as an intersection or some other feature, we'll have to address that. Shoulders, we never did run inertial profilers on shoulders. Miscellaneous areas, that really hasn't changed. Okay, item 6 here, areas within 15 feet of the beginning of an approach slab of a structure. That was in our spec already. And it used to say even 15 feet beyond, but now it says 40 feet. So we changed the 40 feet off the trailing end of a bridge because you're still getting roughness measurements as you're coming off a bridge from bumps you might have hit on the bridge or at the joint. You can still be bouncing as you're, so most of that IRI, most of that roughness that you felt coming off of bridges basically kind of had a tendency to go away after 40 feet, so. Okay, so now I'll go over overview of the construction process. So I'll be going through every one of these. Review the QC plan, witnessing the quality control, witnessing the inertial profiles, reviewing the payment request, and then calculating an adjustment. And at the end, basically we want to get all this data submitted. So now I put these green cones up there for a reason, because I recently went through a project and I saw green cones on the shoulder. And they were right where the leave-outs were. I'm thinking, wow, that's a great idea, right? Because these cones are what the contractor uses. You can put a reflective sleeve on the cone, and as the inertial profiler runs by it, it'll automatically sense it. If he hits a button within a couple seconds or something, that's how the inertial profiles work. Well, if you put a bunch of orange cones out there, the contractor's probably going to pick them up. If he sees a green one, or a different color, the guy that's picking the cones up is not going to accidentally pick up that semi-permanent reference point. So, saw that on Highway 50 between Sunrise and Eldorado Hills. Okay, the quality control plan. The quality control plan ensures all existing profiles line up with the contractor's initial existing profile. So on most of our projects are asphalt. We don't have that many concrete files. That would be the pave profile if we were talking about our new concrete lane, because we have the pave in the final only. So we want to make sure that every profile lines up with the first profile that we run. So this quality control plan, we talked about that previous. I'm going to say it again. These semi-permanent reference points, they got to be locked in and people got to use them. If they don't use them, this is not going to work. We're going to have major problems with making these payment adjustments. Okay, so anybody that comes out to that job with a profiler, they're going to use the same station and the same direction of increase. The organization certs, contact information, responsibilities, that layout plan sheet, that's the plan sheet that's going to have all that information. Anybody that's going to run the inertial profiler will have. They'll basically make sure they use the correct plan. So, okay, the contractor's profile runs. So now we're witness. So when the contractor goes out and runs his existing profile, the specs require him to basically let us know ahead of time so that we can witness. Time frame is, I think it's 2 days ahead of time. I don't have that up there, but there's a spec that basically says they're supposed to notify us when we have a chance to go out there and witness. They're also supposed to run a video. So then they're going to give us the electronic copy of that drive. So they're going to give us, a thumb drive that hopefully has a video on it and all the PPF files on it. So, and also we're doing that for the baseline. So why do we care about these videos on these two profiles but not these other ones? Well, we can go run these other ones again later. They're always going to be there. These are going to get covered up with pavement or ground away inward. So also, with our percent improvement specs, the rougher when the contractor goes and measures this existing profile, it's to his benefit. I'm not saying a contractor would do this, but if there's a pothole that's not in the wheel track, if you can drive through that pothole that's outside of that wheel track, that existing MRI is going to go up, and he has a chance of increasing his incentive. So the intent is so that we have a good record of where that profile was run, and what the conditions were. So our specs also we don't need an actual video. So most of these profilers they're selling now have the capability of taking a picture every X many feet, and we're saying every 52.8 feet. So that's basically one reflector. Every time you're driving down the road, if reflectors are 48 feet apart, you'll see a picture every reflector, right? So we don't need that many. We don't need huge files. We just want a photographic record. Okay, so we'll get that video or those pictures every 52.8 feet for the existing and the baseline. And all these profiles got to be submitted directly to the engineer within 12 hours. We're going to check. We're going to use these later in the payment process. Okay, so the payment adjustment spreadsheet. The specs require the payment adjustment spreadsheet, and this is basically requires the MRI data to be pulled directly out of ProVal. So in ProVal, when you run the MRI, you can run there's a lot of different reports ProVal will run. The one that we're going to be going into is called the Ride Quality Fixed Interval MRI Report. Those are I named it that. I didn't name it that. That's what a lot of people call it, but it's the buttons that you're clicking in succession to get to that actual report. So it'll give you a table of all the MRI values, the beginning station, the end station, the segment length, and MRI value. And all this tabular data is going to get exported out of ProVal into this spreadsheet. And the rule is it's got to be a direct export from ProVal. There's nothing to stop a contractor from taking those values and then changing them on the spreadsheet other than you're going to check them. You're going to be doing the same thing to make sure that they didn't change any values. The spreadsheet takes care of that. Okay, so then we're going to obtain the worksheet. This is now online here. We have a worksheet for HMA, and I just went through this with the representative from CalAPA last week, and we double-checked it and triple-checked it. We feel it's working exactly the way it should work. So, not to say that there won't be a bug here or there that we might have to fix, but we're confident this thing's working now. We have a sheet for the concrete and the grind existing concrete under development. So those are very easy sheets. So when I walk through these worksheets for HMA, the most complicated one, if you can do that, you can basically take the next step for concrete or grind existing concrete. They're very simple. Okay, so contractor payment request submittal. It's two files. There's an Excel file and a ProVal project file, a PVP file. These go together. Information from here goes into there. You're going to get that ProVal file, and you're going to pull that same information in to make sure they didn't change any values. Okay, and then, so this slide here is meant to basically explain the fact that when you open up these specs, you'll see a lot of tables. And it's a bit overwhelming when you dig through these Smoothness specs. It's very overwhelming when you look at it. And you try to digest all the rules and everything. Well, it's all built into the spreadsheet. So you import these profiles in, and it calculates everything per the spec, and it does all the checks for you. And we'll walk through what that does. So one of the functions, let me cover the yellow cells here. So, like any black box, you don't really need to know what's inside that black box. We have input that goes in and output that comes out of it. We can take some. We can dial some knobs in to change it a little bit. So we have to basically tell the spreadsheet, what the pavement type is. Is it HMA? Is it open graded friction course on existing? Is it open graded friction course on new? We have to tell it the opportunities for improvement for that lane. We have to tell it the layer thickness. We have to tell it if there's any pre-paving corrections. We have to tell it, did the contractor address all the ALRs? There's no automatic function for this. You're going to have to go into ProVal and look at a screen and say, yeah, I agree with you, contractor. You resolved all the ALRs. These are basically just zeros that we're going to put into a column, 0 ALRs. And then we have this other checkbox here. It's called Pave or Final, and we'll cover that a little bit later. But we're going to use the Pave file for the payment adjustment. And if it is in a must-correct zone, a mandatory correction, the contractor has to go out there and correct it, and those values will show up on the final profile. So if you want to use that final profile as the payment adjustment, you check that box. So when you check it, it's going to go find that final MRI value, and it's going to make sure that we don't pay for, we don't pay for grinding into correction. If the contractor had a deduction and you check that box and they ground into correction, the contractor's not going to get an incentive. He'll just get 0 adjustment. So engineer's going to verify the contractor's data came directly from ProVal. The spreadsheet does that. Contractor's profiles are aligned. When the contractor brings all these profiles, if they're not aligned with each other, there's some checks in there where there's a bunch of things that go red, and he's going to know right away, and he shouldn't be submitting that to us if it shows that there's misalignment data. And there's a section where we can import our verification profiles to compare them to the contractors. Are they within? We have to do 1 profile per 10 of the contractors. That's our minimum requirement. You should do more. You should do more if you can. We're just going to compare 1 profile to the contractor's profile, ours to theirs, and if it's within 10% overall MRI, then it verifies. And obviously it calculates the payment adjustment. Okay, now this is the spreadsheet. All these yellow cells are input, so these are all generic information up here. And down below here's where the dollar amount is calculated, when everything's in compliance. If something's non-compliant on this lane, it's going to show non-compliant. He's not going to get an adjustment. So this is a different view of that same spreadsheet. So this spreadsheet's essentially a bunch of worksheets. So we have the front payment adjustment worksheet is what we're looking at right now. We're basically exporting the data from ProVal into each one of these worksheets in the back, and it all gets brought forward. These green tab worksheets are for the contractor, and the orange tabs are where we import that same data to make sure the contractor didn't change anything. So we have to basically tell the spreadsheet, what's the layer thickness, what are the total opportunities for improvement. In the HMA type, that text is kind of small, but there's a drop-down list for some selections there. These 3 cells here, they define what spec we're going to end up using. Okay, if I say there's 1 opportunity for improvement, this 1 gets carried down all these yellow cells here in this column. Each one of these rows is a different segment. So I might have a segment where I have to increase the opportunities from 1 to 2. I can do it at the segment level by putting, just going to that segment and putting a 2 in there. Okay, so this yellow cell over here, this column here is, the contractor's got to put zeros in there to indicate that there's no ALRs in each one of these segments. Every row is a 10th mile segment. If he doesn't put a 0 in there, or he puts something else in there, this text is going to get struck through and he's going to get a non-compliant up here. Then we have some other input over here for full width segment corrections and partial width segment corrections. You'll check those boxes if you have full width or partial width, and we'll cover that. This looks overwhelming, maybe, to some people. It does, yeah. You're importing a table into 4 worksheets, and you're selecting a couple yellow boxes. There's a lot of information. This is going to be your backup for your payment adjustment, that dollar amount. And all the backup information you need is going to show up on that sheet. Okay, on that last worksheet, this is the one that's a little bit different. We're going to basically do some checks. The first check we're going to do is make sure that the contractor didn't change any of his data. So there's 4 columns of data. It's shown off to the left here. If there's any differences in their data versus our data, we're going to see what the differences are. These will go red with some values in them. If they all match, it'll be all green here. That means the contractor didn't change any of their data. On the final worksheet, you'll have this same table on every one of these on the existing baseline and paved. So that's the check to make sure they didn't change their data. The next check is, okay, the contractor gave us a ProVal project file that had all those 4 PPF files in there. We want to make sure that those 4 PPF files are the same files that he gave us that day in the field, or daily in the field. So we can import from ProVal an overall report and get all the MRI values that are in that ProVal project file. Then we can look at the actual values from those individual files. We can kind of compare to make sure that the MRIs are a little bit different. They might be a little bit different because the contractor might have had a jog. He might have accidentally left a leave out. So we're going to be checking the overall to individual PPFs. Oops. Then the last one is where we bring in our verification value. So here we ran a final profile, and we had a 53, and they had a 50. So, we're 5% difference from them. It's less than 10, so it's verified. So you don't have to check every one of these, but you should. As a practice, I think I would do the final one on every project for sure. Okay, then once we have everything agreed to on the worksheet, we calculate the adjustment and make it a payment adjustment. So contractors the resident engineers has their supplemental fund allotment for this incentive adjustment. You can write a change order ahead of time and encumber those funds so that monthly you can turn the X-work bill in to make that payment adjustment. Similar to how the asphalt index adjustments are done, and some people used to do QC/QA that way. Okay, so in the end, once you make these payment adjustments, we're requiring the engineer, the resident engineer, to submit these spreadsheets to headquarters, to these websites. If it's asphalt, submit it to that, asphalt.smoothness@dot.ca.gov. If it's concrete, concrete.smoothness. So what we're going to do is take all this information, and we're going to analyze it, and then we can make recommended changes, or maintenance, division of pavements can look at improving their specs. So this right here is a common way to look at some of these MRI values that we have. We have an existing surface that we're overlaying. Here's MRI values from 0 up to 140. And here's a final surface. So, this was the Highway 50 project that went, one of the lanes that went from Sunrise Boulevard up to El Dorado Hills. Most of their pavement that they were milling and filling was in the 60s to 80s. Some of it was close to 100. They paved all that back, and they had one in that lane that was 58. That's smooth. Most of their paving was in the 30s and 40s. So, this project right here, if it was on an disincentive project, they would have earned the incentive on every fixed increment. I can look at a project that was right next to that, where it was the same structural section, different contractor. Existing MRIs were the same, and they paved 110s, 120s. So contractors, would they pay attention? They'll obviously do better paving. When they're trying, they can pave smoother. When they're not trying, they don't need to pave so smooth. And in the past, a lot of our projects just had a straight edge spec on it. It was kind of like they know the RE's not going to get out on his hands and knees and push a straight edge through the whole project. We're measuring every project now for smoothness, so they have to pave smooth. I mean, there's no other way around it now. So.
Oh, just quick question on that.
Yep.
How are you differentiating between the existing and final?
Oh, these are so this, I basically took a table, and I had all the existing MRI values beforehand. I got all the profiles lined up. The profiles were lined up, right? So if I looked at this dot right here, that's 1/10 mile segment. I would have had an existing MRI value of, say that's 58 right there, right?
Uh-huh.
I know that.
Okay.
I have an MRI report, right?
Okay. So
They milled it out, they paved it back, and they ran it. They ran their MRI, their inertial profiler over that, and figured out the MRI. Now this MRI was 27.
okay. I guess I see it.
Yeah,
I do see it.
yeah. Okay. So, and there's a line here. I mean, you could there's a function in Excel to come up with an average line based on all that data. But
So some of the formulas that industry brought forth were based on,
some data that they thought they had. We didn't necessarily have good data on the Caltrans side to refute it. So when they said that when they came up with the achievable smoothness limits, which was 0.3 times MRI existing plus
35.
35, excuse me, for percent improvement, we didn't have a lot of data to fight back and say, okay, that's a good number, not a good number, that's a good formula, not a good formula. So over the coming year, we're going to study the data a little bit. We're going to try to see, how, if the existing pavement is, 150, how smooth can you get it, right? So, in a mill and fill operation. So, they're saying, that mill and fill is not going to get that, smooth.
Yeah.
So that's what we're looking to do, basically, is gather the data that we have from existing jobs, go back, look at it. We're going to form a group with industry and Caltrans and look at some of the data. So that's basically what we're wanting this from your slide.
Yeah, so the other part of these mill and fill projects, right? This was a project where they were just milling out old open graded that had a lot of longitudinal joints were falling apart. The lanes were in decent shape. The MRI was 60s to 100. It wasn't bad, right? 60s to 90s. That was the definition of a good pavement's 95. Anything less than MRI of 95 is good. Over that's fair. But I mean, this pavement could have had a lot of potholes in it, right? And our MRIs would have been way over here. When they milled that out, that mill doesn't care if there was a pothole there, right? He's going to mill it out. They probably could have just paved back to those same MRI values. So. He has a question. We're videotaping this, so we'd like to make sure everybody can hear it. Hey, Deborah, we're doing questions. Yeah, okay.
So you mentioned the bidding package for will include existing MI.
Yeah.
So then the contractor will run their existing and and then it varies more than 10%. Which one do you use to compare for incentive?
Okay, we're always going to use the contractor's existing profile, always. The one that was from pre-bid is just to check if there's a differing site condition or something changed. We're not saying if it's 10% different that we're going to make any adjustment to we're not right to change it. We're just saying let us know, so we'll look at it, right? I mean, there's no magic equation that you can just come up.
Sometimes there's a lot of time between when we do ours and when the job actually gets bid.
Yeah.
It might affect it if the roadway's got a high ADT.
And then the other part is Blair was talking about comparing data before and after and all that. I mean, we were getting all this data in from all these projects, not all of them, but a lot of data. But nothing was aligned, trying to make heads or tails of all that data wasn't very feasible. Now we're requiring the contractor to give us all this profile data aligned, right? Now we can,
So if you look at the section 36 specs, they talk about trying to resolve differences with Caltrans and the contractor and try to work to resolve these differences. But there also is a section about, third-party dispute and going out and employing a third-party dispute, and then, whichever one is closer to would be utilizing the one that's there. But, it's in our best interest to try to work these things out, right? And if you're right, if it's been a long time since we've gone out and run the profile, and it's not that close, not that far off, I mean, you're probably better off, accepting the contractor's data and moving forward with the project. The specs are going to pay them a little bit more of incentive, like Pete was saying, if it's a percent improvement job, if the pavement got a little bit rougher. There are target zones in these. We've got wider target zones. We don't have the hard line 60. I don't think you're going to get into all these fights over, unachievable pavement. And you'll see that as we get into some of the pavement smoothness values in the afternoon.
Yeah, this is not typical. This is an exceptional paving job. Most jobs you'll see are up here.
Yeah.
I'm just kind of made a point of this. I drive over this every day.
Yeah.
And it's like, man, this job rides really well. So
we're getting close to our break, and we'll power through a couple more of these slides here.
okay. Now it's not advancing. Space bar or arrow key. Okay, we'll use a space bar from now on. So this slide shows a lot of web links. So the top web link is to the division of the Office of Pavements web page. It's got a lot of information in there that designers have access to. Construction, we have a web page now. It's the DOT. It's basically HQ Construct/Smoothness. We're making all of ours external. We have nothing to hide. So you click on that, it's going to redirect you to another link. It's called construction.smoothness because it's ADA approved. On that, you'll find the pavement adjustment worksheet for HMA. Soon you'll find the concrete and the grind existing concrete. These smoothness adjustment guidelines, we're putting these out, and these are going to probably be out within the week. We're just going through some final edits on it. There's a video online right now for how to fill this payment adjustment worksheet out. You know, it's basically going through all the steps a contractor will go through. So that's online. There's other links in there. Okay, for more information, we'll have this construction administration guideline.
All right, we'll go ahead and get started. So, just got a couple of videos. So maybe it's been over a year, about a year and a half ago, I went back to, it was an intelligent construction conference, and they actually had a lot of these TopCon, Trimble, CAT, all these people are kind of gearing up for kind of intelligent construction technology, and there were contractor people, there were other DOT people there, and I was fortunate enough to get TopCon guys were handing out some of the like a thumb drive with some of their videos. But this is basically a video I kind of want to share with you guys. This is, you know, they're gearing up towards contractors and trying to reach out to contractors and show some of the tools and technology that's out there for contractors to do things like 3D milling and 3D paving and some of these things. And this video is just it's a concept video, but it shows and talks about how TopCon and Trimble are going after and to assist contractors in achieving pavement smoothness through 3D milling and 3D paving. So, you know, so far we've been a lot of theoretical, but I just wanted to share this video with you guys. I'm not saying this is what every contractor is doing, but these tools are out there, and just to give you a little insight into this. So I got two quick little videos to play. So that's a little bit of a promotional video for TopCon. I'm not trying to promote TopCon. That's obviously a means and method. Our spec isn't really a means and method spec, but I just wanted to share with you that, you know, there are, you know, in the construction industry, there are a lot of, you know, competition out there. You know, the surveying companies are trying to promote and assist the contractors in achieving smoothness, and there's systems out there that can help them achieve smoothness. So I just want to share that with you guys a little bit. I got one other TopCon video that just briefly shows the 3D paver. It's a
Okay, can you hear me back there? Okay. Okay, so I covered section 36.3 changes. That was the general changes to both concrete and asphalt. Now we're just going to go through the changes that apply to asphalt. So one of the big changes has to do with the layer thicknesses. So in the past, we had these two different type of jobs, thick lifts and thinner lifts, right? We had a 60 spec, a 60 MRI spec, and a 75 MRI spec. Years ago, when we first started with an MRI requirements, we basically said the 25, if you had 25 hundredths or greater, you went with the 60 spec. So that has been now changed to 3/10 or greater. You go with the 60 spec, and now we're calling it the 60 target spec. So the purpose of this table here is just to show you the 5 different ways that we try to express 2 different things. So we used to say greater than 2/10, that's the 25 hundredths. That was going to be the 60 table. And we bumped it up to greater than 25 hundredths, which means 3/10 or greater. And we basically said the same thing, but just greater than or equal to 3/10. So we're using the 3/10 terminology to have people better understand that if you have a 3/10 lift, that's the tighter spec. because you can break those lifts up into 2 lifts typically. So the other change is that with our new specs, if you had a 3/10 lift, if you looked under the old specs, you basically had to place one lift of 3/4 inch type A. Well, that table with the lift thicknesses and layer thicknesses, that's changed now. You can use 1/2 inch HMA, 2 lifts of 1/2 inch HMA, 1500s. Smaller aggregate, a lot of people don't like that, but that's how that spec reads now. So if we have a 3/10 lift, we can do two lifts. That's going to be 2 opportunities. To promote smoothness was one of the other reasons. So, is there any questions on that, or there might be a question on this later, so remember that answer. Okay, HMA smoothness MRIs, it's a moving target. So this little guy here on the left is kind of to simulate, it's a moving target. If we're overlaying a HMA on existing pavement that's relatively smooth, it's not a moving target. If it's rough, we're going to adjust the spec limits up. It's a moving target of what we're shooting for. And it can vary by every 10th mile segment. So normally you would go into Pro Valley and say, okay, what's my MRI requirement? Oh, it's 75. You could get your MRI report and say, look for all the MRI values that are over 75, you got to correct those. If we're overlaying rougher pavements, you can't do that anymore. All that data's got to come out of this ProVal into a spreadsheet to determine if it meets spec or not. So that's the tool that we're providing as a spreadsheet. So this slide here basically gives you an idea of when we go to this moving target. So when we talk about a moving target, when you hear the term percent improvement, that means it's a moving target. The specs adjust up if you're overlaying a rougher surface, which makes sense. If you're going to overlay a road that's really rough, 200 inches per mile, and we had a spec of 75, it's difficult for the best of pavers to get a 75 on something that's 200. So we're going to raise the spec up a little bit. So now our designers have to kind of design for smoothness. You know, they need to build in 2 opportunities, either milling in one shift and paving in a different shift, or a thick enough lift where they can break it up in 2 lifts. You know, designers have to account for that now. In the past, they basically just put a lift out and say 1500s, you got to get a 75, and you know that led to a lot of claims. So we're going to make all those claims go away. We'll still get claims, but they won't be as legitimate. Not that they were legitimate, but okay. So when we have greater than 3/10 or greater, you know, we're going to use the 60 target spec, and if we're overlaying an existing road that's over 165, then it goes to percent improvement. If we're doing these thinner lifts, less than 3/10, you know, we're going to use a 75 target. And if that pavement gets too rough, we're going to adjust the spec up. If it gets rougher than 135, then we're going to say, okay, you know, you're going to have a moving target. So
For each 10th mile segment.
yeah, okay, so this applies for every 10th mile segment. So I might have a 10th mile segment that's going off this. Let's say I have a 1500s lift. I'm going to be using the 75 target table or the percent improvement table. I might alternate back and forth between this table and that table and this table and that table every other 10th mile segment. It's going to adjust for itself. So okay, so
Can you go back one? The ALR also is.
okay, oh yeah, I forgot to cover ALRs. So in the past, we had the ALR requirement. That was the localized roughness requirement. That's the requirement for if it was a must grind. If we had an ALR that was over 160, we say you got to fix that bump. It's an isolated bump, you got to fix it. So if we go into percent improvement, now it's basically, it's going to get adjusted up if it gets into the rougher pavement. So there's a higher threshold. So this spreadsheet that we have will tell you what that spec limit is. If it's not 160, it's going to tell you when it's other than 160. Okay, so now I'm going to talk about these thinner lifts. They're not thin lifts, but they're thinner lifts. They're less than 3/10. So typically, when it's less than 3/10, it's always one lift. There are some exceptions to this. Sometimes you might do type A covered with RHMAG. You might have a 10th and a 1500s would be 2500s. That's 2 lifts, but still we're going to use that 75 target table. It's just This spec is based on, just on lift thickness. So if it's less than 3/10, it's going to go off the 75 or percent improvement table. Okay, so when you open up these specs, one of the first tables you come to is this section that says you're going to figure out what pay table you have to use. And there's the table that covers what we just talked about on the previous slide, greater than and less than 135, and we have, you know, these different sections. There's a lot of characters on that section number, but we have sections A, B, and C. It's 75 or PI, it's B and C. And here's the table. This is the adjustments. So if we have this is the 75 target table. So we're calling this a 75 target table, but the contractor could leave a 90. He could pave a 90 MRI and he wouldn't have to grind it. In the past, he'd have to grind that down to a 75. But we're going to take a deduction of up to $1,350 per 10th mile. So, you know, he has all the incentive he needs to try to pave as smooth as possible because he doesn't want these disincentives. If he paved to 85 or something, he could grind out of it and get into full pay, but he can't grind into the incentives. So, you know, all these values, these are covered in the spreadsheet. This is the percent improvement table. There's one table that covers, you know, both layer thicknesses, greater and less than 3/10. On the right, we see the percent improvement table for less than 3/10. We have the same dollar adjustments. It's just this equates out to, if you're 125% of target, we'll talk about what target is, but this equates to a $1,350 deduction. And the max incentive is $450. If I go back here, we'll see the max incentive $450. Incentives and disincentives are the same under both of these tables. We're just raising the target limits. Okay, so percent improvement. Now, it's based on, when we do a percent improvement spec, we basically got to say percent, what is it we're trying to figure the percent improvement of? So if I can, we have to come up with a target value. So we talked about the 75 target. If I have a 136, that's over 135, I'm going to have to calculate MRI target. If I do that math for one equation, I'm going to essentially come up with a number that's just above 75. So if I get a 140, it's going to gradually climb up. So these target MRI values, you know, it's a function of how many opportunities for improvement you have. So when you go to that spreadsheet and you enter the number of opportunities, it's going to calculate all that for you. All you need to know is what an opportunity for improvement is. So.
Can you go back? So if you had one opportunity, you use the 0.3 times MRI not plus 35, you have two opportunities that uses the other formula. If you have three opportunities, it uses the third formula.
Yep. Okay, so I guess I should throw out an example. Let's say we had an existing road that was 200 MRI. There's a 10th mile that's 200. And all I'm doing is putting one lift on it. And I'm not doing any milling and filling, or I'm just putting it right on top of a 200. My target value is going to be 200 times 0.3, which is 60, plus 35 is going to be 95. So that target value that we had of 75 now just got raised up to 95. So if we had two opportunities, I'll have 9% of 200, which is 18 plus 45, which is 55, 60. It ends up being right close to, it ends up being less than 75, but it's going to bottom out at 75. So there's some general rules here that when we calculate these targets, for lifts that are greater than 3/10, when we calculate that target value, we're not going to let that equation give us something lower than 60, because that would make the spec tighter than what it would have been if we just had the 60 table. And if we have a lift that's, you know, was under the 75 target table, we're not going to let it spit out a value that's less than 75. Okay, so all these tables that we saw before, this is kind of the way I look at it here. So the x-axis here is what we call in our spec MRI 0. This is essentially, MRI 0 is the lower of the existing or the baseline profiles. It's the surface that we're typically overlaying, that we're trying to improve upon. And here's our final MRI values. So here's our 135 number. So if I have an existing surface that's 135 or less, we're just using the 75 target table. So there's our 75 target, and these two red lines that's our deduction range. If we go over that top red line, that's our mandatory correction level. if we pave smoother than a 75, we get the incentive, but we've got to be, between these two green lines to get any kind of incentive, and it just maxes out the incentive. So that job that we looked at, they were paving, that plot of circles that we saw was, roughly in this area. If we plotted those plots on that last project, we would have been about here. So if I'm paving a rougher surface, the calculation I just did, 200, there's our number. It's going to be whatever that number was that we calculated. It was 95, I think. There's your 95 value. And then we basically go up from that 10%. We had 10% on a 95, and then we also had 25% on a 95 to figure out those values. So the rougher the pavement, the targets gradually rise up. And there's our MRI target value. There's our equation right there for a single opportunity. So if we have a project that is calling for a single lift and there's no other opportunities for improvement in the plans, in that existing surface out there is, in the high 100s and the 200s, we could end up accepting a pavement that has a 120. This purple line is that's what the FHWA calls the difference between a fair and a good pavement. It's 95 MRI. We don't want to go out and pave a project and end up with a surface that's fair. We want good. We want below 90, obviously. So we would never really want to accept a project up here, but we might have to if they don't design right. So, designers are being trained to basically figure out how to put two opportunities in. So this is the one opportunity for less than 3/10. So if we go to two opportunities less than 3/10, we're in the percent improvement table, but when you do all the math and all the rules, it basically, we have the MRI target value for 0.09 times MRI 0 plus 45. That's this value, but basically what it happens is it can't go less than 75, so it goes flat. So we're in the percent improvement range. And then the incentives and disincentives are based on 10 and 25% above that number, which is a little bit different than the 80 and 90 that we had under the regular target tables. So designers are being trained, like if you have an existing surface that's over 135 up to in the 300s, having two opportunities, we're going to end up with, we're going to, by spec, we're going to get something less than 95. So in most cases, contractors are going to be probably paving into incentives. So one opportunity, I'm going back, in the past, we might have been overlaying a road that was 250 when we told the contractor they had to pave to 75. And they file a claim. They say, it's not reasonable. Well, we just, these specs account for that now, so.
Pete,
Yeah,
how do you guys define mandatory correction? What is that exactly?
okay, all right, so a mandatory correction
Can
is,
you repeat the question?
okay, the question is, how do we define what a mandatory correction is? So, okay, so when you go to our tables, that's the highest MRI value that you can have that's acceptable. So if we have a 75 target table, that's, we're doing a single lift, we're doing a layer that's less than 3/10. Our mandatory correction level, you go to our table, it's 90, so we can go back to that table. There's that 90 value, that's the mandatory correction level.
No, I think what I meant is what entails, when they're in the mandatory correction, what does that entail for the contractor?
Grinding.
Grinding?
Grinding to get down to the acceptable limit. So if you got above a 90, if I got a 95, I paved it and I got a 95, and my existing MRI was below 135, so I'm not in that percent improvement range. I'm in the target 75, hard target 75 range, and I paved it to a 95. I have no choice. As an RE, I have to tell him he needs to bring it down, and it's mandatory
Okay,
correction.
so they're going to grinding pave.
Yeah.
Pave.
Yeah, so here's the big difference is, like, in the past, we had the 75 target. In the past, we had the 75 MRI spec limit, right? If they paved to 76, we couldn't accept it. And they'd have to grind. Well, nah, it doesn't really make a lot of, it depends who you talk to if that makes sense or not. That's a threshold. Well, there's a lot of projects I saw that were paved in the 80s, 85s. You drive over them, you can feel it. It's not the greatest paving. But to get to a 75, you got to do a lot of grinding because there's a lot of little bumps. You got to grind a lot of little bumps. It's not just like a couple big bumps you can take out. You can require a lot of grinding to not do a lot of improvement. right? These specs address that by just taking a disincentive. Giving the contractor the incentive to use their best paving practices. Everything is getting measured now. In the past, it typically wasn't. And, in the past where we had, you'd have an RE on one job where they paved at 80. And that RE, says the spec says 75, they can't accept it. They go out there and grind. And they finish grinding all those 80s down to 75s, the whole job is ground up. You get to the next job and the RE kind of felt sorry for them, right, and didn't enforce the spec. It's still, we have to be consistent throughout the state. So these new specs are going to, improve that. So, is there any questions on this yet, or?
So if cold planing is involved, is that considered an opportunity also?
Okay, yeah. Okay, so the question is, if cold planing is involved, is that an opportunity or not? That depends. Okay, so the way the specs read, if you can cold plane in one shift and pave in a different shift, that's an opportunity.
No, it counts as a single opportunity.
That's an extra opportunity, right? If I have to mill out and pave back in the same shift, which is how our specs default to, unless that's not an opportunity. Now, you could talk to everybody in the world and they'll say, well, that's some type of opportunity, it's only intent. Yeah, that's kind of an opportunity, but it's not in our specs.
Right. What
So-
is the difference between if you pay the same shift?
Okay, so,
You have enough time to prep for the.
yeah, so when you pave in a different shift, okay, if you have a job that requires you to mill out and fill and pave back, typically you're milling out, right, and then you got to pave back flush. That adjacent lane is, your rollers are going to be having to ride on that adjacent lane. That doesn't help you, right? If you could mill in one shift and pave in a different shift, typically you can do the adjacent lane.
Yeah, I got it.
That will help you, right?
So
So,
you can grind, probably 2 miles before you pave, then
Yep.
you have more opportunity.
yeah. Then also, there's like this example project I was telling you about, how they got those great sections. They had a mill, they had the spec that allowed them to cold plane the surface, leave it exposed for up to 7 days, and so what that contractor did, they went in, it was 3 lanes in both directions. They went and started in one lane, milled it out 2, 3, 4 nights, came down the other number 1 lane. They were running traffic on that surface. It was a micro mill surface. They used a micro mill. They didn't have to. They just decided to. And then they had there was long enough sections where they can come through with their inertial profiler. Not that they had to by spec, but they did. They ran their profiler over that, and they said, okay, there's a couple spots where we don't want to pave over that. We want to do what we can. They went to great extents to make that really smooth, right? You saw the numbers, the 40s, 30s, some cases 20s. It's unheard of when you talk to most contractors, but they can do it. It's just, that was 2 opportunities because they had, so, there was a lot of, when we were in meetings with industry, there's people in construction who were saying, it's got to be an opportunity. It doesn't matter, if it's one shift or the other shift. Well, there's a little bit of difference, but that's how the specs got set up. Everybody's bidding on the same spec, so it's fair. It just seems like, yeah. Okay, so is there any questions on, this is kind of I like this graph because it just shows you how things, we accept rougher pavement if we're paving over rougher pavement. That's one opportunity. If we could get 2 opportunities, now I could, I could basically get something similar to that all the way up to paving over a 328. So, if designers strive for adding a second opportunity in there, we won't have a chance of ending up with something that's above 95. We'll probably, So anyways, that's, okay, this is a 2 opportunities PI table, similar to the 75 target table. You do the math, that 75 bottoms out at, use this equation and you plug in 328, you'll get the number 75. That's where it crosses the 75. So how do you get a second opportunity? special provisions. There's a special provision that allows, if they use the special provision, they can allow the cold plain surface to be exposed for up to a week. Right now, the standard spec says you got to pay back in the same shift. If they use that, they can leave it exposed for up to a week. Now, there's some districts that say absolutely no way. They've had so many broken windshields. They're never going to run traffic on a cold plain surface. I had a job like that once, and I will never do it. After I had that happen, it was like, never, ever again. I don't pay back in the same shift. So, you got to be, but I did it for years and years before I had that happen. Until it happened, and it was like, oh, you see things differently once it happens. So, 2 lifts, we might break, you can end up with 2 lifts if you have 2 different types of HMA with a less than 3/10. Okay, now we have this thing called full width segment correction. And I'm calling this skim grinding, but we'll cover that in a second, so that'll add a second opportunity. Okay, so we have this new section called pre-paving corrections. So we used to have a spec that was pre-paving grinding days. And that spec didn't work out too great. The spec basically said, go out, contractor, and grind every spot that had localized roughness over 180. Right? There's not really, and we're paying them by the day. There's no incentive for them to be even efficient at it. It was not a good bid item. It was putting all the responsibility on us and nothing on them. And if they had any MRI segments that were over 180, we couldn't enforce the smoothness specs. So the pre-paved grinding day, that bid item is no more. So now we're going to have these 2 other bid items that are possible to use if a district decides to use them. The first one's called full width segment correction. And what that basically says is they got to use a diamond grinder or micromilling equipment. That says diamond grinder here because we want to be fair to the diamond grinding industry. If they can cost effectively come up with a piece of equipment that'll grind a 10th mile as efficiently as a micromill, they can use it. But most cases, I think a contractor is going to use a micromill. The spec says they have to pave over it in 7 days. So if you use this item, your district's got to be okay with running traffic on a cold plain surface. This is a micromilled cold plain surface, which is different than a regular cold plain surface. It's there's less likelihood of windshield damage, but there's still a chance. And there's specifications for the micromilling drum. So we're using the same specs as the cold planing specs for the construction part of it. But we're basically saying, okay, it's got to have this drum on it. The teeth have to be a 1/4 inch apart minimum. So, and they have to be within a 1/16 of each other as far as their depth. So, and that adds, when we do that, that adds an opportunity for improvement. That's how we get 1 extra opportunity. So this full width segment correction, which I like to call skim grinding, it's just taking a diamond or micromill and just dialing it in, putting it on automatics and let it go. Skim off 1/8 of an inch. You're trying to touch the whole lane for the 10th mile from the full 12 foot. You're just trying to smooth it out. So rather than going out there with a diamond grinder and trying to hit a bunch of different spots that would take forever, micromill can just go through it really fast. And we can, if the road will hold up to it. So there's some roads where, if there's a chip seal out there and you're, you probably don't want to take your chip seal off. If it's a rubberized chip seal, you want that as a good layer that you want to overlay. Maybe you don't want to use it. You don't want to skim that off, right? So you wouldn't use that if you're trying to save your chip seal. Then we have something called a partial width segment correction. And this is similar to what we had in the past. We're just leaving it up to the contractor to decide, okay, these 10th mile segments, we're calling them by the each segment. Go out there and give us a plan on how you're going to smooth this out. So they can use a diamond grinder or a micromill. And they also have the capability of using this new 3D modeling. So we saw that in the video. A contractor, there's a subcontractor in Southern California, Pavement Recyclers. They have a lot of cold planers. They have probably most of the business in California. They're buying this equipment to make use of it. So they can scan a road and then, they can have their cold planer go through there and cut to a defined plane. So, we'll see how that works, but that's essentially how that will work. Then when you use this partial width segment correction, it's not an opportunity for improvement, but what we do is just say you're going to use the 60 or 75 target table. you're going to be using this over here. So it's, it's even better. It's a tighter spec. So if they use partial width segment correction, no more percent improvement, we're saying you had a chance to go do what you wanted to do. Figure out where you want to grind. Whatever you do, we're holding you to the 60 or the 75 target table based on your layer thickness. So they've got to provide us a correction plan. So, this, again, these specs are all NSSPs. We all worked as hard as we could to try to make them perfect, but they're not going to be perfect. We'll make improvements on them over time if there's an issue with anything. So, right, pavement guys?
Yes.
Okay.
Just a real quick comment on the partial width segment correction. It should only be one additional opportunity.
Yeah, there's no, you go to that section and it refers you to, basically says you're going to use a 60 or 75. When you go to that 60 or 75 table, once you go to this table, it doesn't matter what that MRI target is. It's just you're using that table. Yep. I know I scratched my head on that one too, but that's okay. Here's a picture of a skim grind. This was a project up on Highway 49 where they're doing some work. They're going to be. This was. Well, anyways, they basically had a lot of ALRs that were. Let me back up. So they ran the inertial profiler through this whole stretch of road. There's a couple miles of it. It's pretty a windy road. There were some areas that were MRIs were in the 80s, 90s, and there's other areas where it's in the 180s, 200s, 210s. They decided, rather than going doing diamond or using that pre-paved grinding day, they're going to go out and just take a micromill and skim grind the whole thing. And all those areas that were over 180, they went down below like 120. And these areas that were 80, 90, which way do you think the MRI went? Up or down? Somebody guess. Nobody's going to. Somebody guessed down. Nope, they went up. So, doing this full width segment correction doesn't always give you a smoother pavement, but if you have high MRI values, in the upper 100s, it'll get you down to, in the low 100s. If you have something in the 90s or whatever, you're probably not going to make it any smoother. So, it's good for just, if you have a lot of rough areas in the high, if you go back to this chart here, if you had a lot of MRIs that were, 200s or 300s, you get that second opportunity, you're going to end up with you'll end up with a smoother pavement. So that's the first pass, and here's the second pass. Here's a picture of a micromill drum. Here's a standard drum, just in case anybody wanted to know what the difference is. And we have it, the specs define what a micromill drum is, so it's got to have teeth that are closely spaced. Right now, the spec doesn't have a minimum thickness, a minimum depth grinding. The intent is to kiss the surface with this micromill over the full 10th mile segment. We're trying to just make the whole thing consistent, so it might be a 1/16 of an inch in some places on average. It might be a 1/4 inch. So, here we were looking at 1/8 to a 1/4 inch minimum depth. And, when you go try to measure that, it's not really easily measure. You're just trying to skim off a little bit. So that's full width segment correction. Do this for a full 10th mile. You get paid one each.
So the only difference between what we have before with pre-paving grinding and this is we're not going to go and run the inertial profiler after they do this full width segment correction. It's
Yeah.
just considered an opportunity to come back in and do their mill or grind or whatever and then pay.
Yeah, so I'll repeat the question in case somebody didn't hear. Correct me if I get it wrong. So once you do this full width segment correction, are we going to require the contractor to run the profiler on that? No. They will probably, but we're not going to use those values. So when we do this full width segment correction, when you go to that worksheet, the spreadsheet, there's the first column of boxes, you check that, and it basically locks in the MRI zero value to be equal to the existing surface. They might go measure that afterwards and call it the baseline if they did some structural section repairs, whatever, and then they did this, they'd have to. But we're not going to use that surface. We're going to use the existing. So, but when you lock that into the existing, they got to make sure they increase the opportunity by 1. So,
So, on jobs that I got to get down below 50 and stuff, we used mills and we set the automatics. And this spec would defeat that because it might be a quarter inch at the center. But we used automatics because they have automatics on them, they can go 2%. And when we get to the outside, because of overlays, it builds up on the outside roadways more often than not. And we would be 3/4 of an inch deep on the outside, and then we would be paid to that. When you use the automatics in the machines, that helps extremely, because we took roadways from 180 to down below 60 because we used the automatics. It wasn't because we were just profiling.
Yeah, so these cold planers, they basically have sonic sensors on them. I think some of the older ones, I've never seen one with a physical ski, but they're designed such that, you know, the cold planer is going to try to cut to as smooth as plane as possible. If these tracks are going up and down on the grade, if it goes over a bump, you know, it's going to want to lower the grinder head a little bit. Did I get that backwards? You know, it's going to want to adjust the grinder head. So, you know, the automatics on these cold planers, they work similar to a paving machine where you're trying to, you know, smooth out. You're using an averaging system where you're trying to, you know.
It doesn't react as fast as a paper.
Yeah, but there's a lot of settings in here. And a lot of these guys will say their software is way better than the other cold planers. And this is the end result spec too, right? We're going to go off the existing. It's to their benefit to try to control this thing to make it as smooth as possible so that when they go pave it, they're going to end up, it's going to be easier to get a smoother pavement. Now, the paving crew's going to come through, they might mess all that up, make it worse, right?
Yep.
They got to use best paving practices and, yeah. Okay, and on this job, they basically, you know, they didn't want to take the yellow stripe out, so they basically let them go stripe to stripe. But when they come back and pave, you know, they want to be skiing off the smoother surface, not off a rougher surface, so. And this is also something I saw in the cold in place recycling over in, there's a couple jobs I drove through where, you know, they had an MRI requirement on top of the CIR surface, and it was really rough. They just took a micromill and they skimmed around the whole thing, and they left the stripe in there. And I put my left tire up on the stripe when there was no cars coming. My left side of my car's bouncing like this, and the right side's smooth. You know, you could feel it. You could tell the difference. It was a big deal. You know, this smooths stuff out. They run this correctly, so. Okay, partial width segment correction. This is all new, right? So the contractor develops a correction plan using diamond grinding or micromilling equipment. You know, isolated sections, they can do isolated sections or wheel paths, or they might cut a path for their ski to ride on their paver. You know, there's Don Matthews from Pavement Recyclers. He's got a lot of diamond grinders. He's got a lot of cold planers, and there he has some diamond grinders. I mean, he's big on saying, you know, you need to cut a path for your paver for the ski to follow. The smoother your reference, the smoother your paver will be, you know, which is true. But okay, you know, alternate, they can use some 3D modeling software. You know, that's, I threw pictures in here trying to show what, you know, they might be using. They can scan the surface and come up with a model. You know, when they put this plan through here, you might, you know, they shouldn't be changing cross slopes or profile grades. You know, we're in general just keeping the same cross slope. Okay, so that was we covered everything for the layers less than 3/10. Now we're going to go to the thicker lifts. So these are basically lifts that are 3/10 or greater. So we know that we can always pretty much break these up into 2 lifts. Here's the spec. You know, just a starburst, just reminding you that now if 3/10, the contractor can break a 3/4 inch type A, break a 3/10 lift of type A into 2 lifts of 1500ths. Our tables are designed so that, you know, we don't want the contractor placing less than 1500ths because then we can't pull cores. We can't do density tests. So we always want the density spec. So we're not going to let a contractor place less than 1500ths. Unless the overlay says overlay a tenth, then you have no choice. But if you have a layer 1500ths or greater, you always have to place 1500ths because we want to be able to pull a core. That's how our specs are set up. Okay, so if this existing surface is over 165, it'll kick into percent improvement. If it's less than 165, we're just going to that 60 table. There's that first table that we talked about. That's where it refers to those. Here's the 60 table. Now instead of a $450 max incentive, we're paying $900. And the disincentive is 15 times 190. I think that's 2,850 minus $2,850 per 10th mile. If they, if they left an 80, if they paved an 80 out there, we'd accept it. Where in the past, we would have made them ground down to 60. But we're going to take a deduction. So that's the same percent improvement table, the 900 and the minus 1,350, but using percent values now. So when you look at this table, this little graphic here is the A team, right? So this percent of target, you think like 75% is not as good as 100%. Well, this table works the other way. We're targeting a number. We want smoother, which is lesser. So the lesser the target, the lesser the percentage of the target, the higher the incentive. So, okay, now this is the percent improvement for 2 ops for 3/10 and greater. So there's no reason to come up and plot something for 1 op because it'll never be 1 op. So if I have a surface that's over 165, I'm going to use this 2 op table. Maybe I have 3 ops, so I'll use that other equation that makes it, if I use a 3rd op, this line essentially goes flat. So now these specs, there's kind of a step in there, and that's how our specs work right now. This is kind of might be an administrative issue, but our mandatory correction level, when it's less than 165, is 80. When we calculate our target using these 2 ops, we end up with 60 at 165, but then we add 25%, and we don't get all the way to 80. We get to a little bit less than 80, so you might have to fix that in our NSSP. So, if these projects have that are 3/10 or greater, you can overlay some pretty rough pavement, and we'll be assured to get decent pavement in the end. So, okay, so acceptance criteria using percent improvement, a single lift of asphalt. So our specs define what an opportunity for improvement is. So it's a single lift of asphalt. So it says where an HMA layer thickness allows the layer to be placed in more than 1 lift. The number of opportunities will be equal to the maximum number of lifts the layer can be broken up into, not what the contractor decides to break up the layer into. So, it's rare that we're going to see a job with 3/10 of HMA. But if you do, and the contractor decides to use 3/4, or if you write a change order and say, I don't want to use 1/2 inch, I want 3/4, now you're changing the character of the work, but it's going to be 1 opportunity. If you let the specs ride the way they are, if you got a 3/10 or greater, and they decide to use 3/4, the contractor's going to argue that's 1 opportunity. You're going to basically tell them, no, you could have broken it up into 2. That's 2 opportunities. You just lost 1 of them. Still 2 opportunities. Okay, micromilling or cold planing not in the same shift as paving. We talked about that earlier. That's basically how that spec reads. So if you have the standard special provision that allows the surface to be open for more than up to 7 days, then that's an opportunity. But if you don't have that special provision, and the specs default to forcing you to pave over that cold plane surface, the same shift, and it's not an opportunity. Okay, so the percent of target, that's basically, there's an equation for that. We calculate that target value, and then we basically look at our MRI segment. We call that's a final MRI value. It's just 1 number divided by the other. If I had a target of 100 and I paved to 75, I'd have 75% of target. I'm going to get my full incentive. I think that's an extra slide that I already covered. I should have hid that. Okay, so now again, here's this black box again. We're going to take all those profiles. We're not asking the REs or contractors to go look at every 10th mile segment and go to those tables and figure out which one you're going to use. Put it into a spreadsheet, and it just does everything for you. So, we're going to check all the same stuff that we talked about earlier. Did they change their data? Did the profiles align? Did we verify them? We get a payment adjustment. Okay, so now here's the guidelines for the design of asphalt concrete pavement smoothness. This is design's guide that provides the designers, the knowledge they need to go design for smoothness now. Like when you say design for smoothness, it means, did you put 2 opportunities in when you should have? That's designing for smoothness, right? If he didn't, guess what? You might end up with a pavement that's over 95 that we have to buy, right? So that's what, and a lot of districts might be okay with that. It's a rural route. We